Hi, in this lecture I'm going to talk about the analog and the digital signals. First thing, the analog signals. So the analog signals are transmitted using a continuously changing quantity as a reference. Data transmission consists of sending signals as continuous waves, which means that the analog signals are transmitted using a continuously changing quantity. So that means that for every value of the voltage, it has a specific meaning or a specific reference. So we transmitting our code or our data using the changing of the values of the voltage over time. So that means that the data transmission consists of sending signals as continuous wave. So this is a continuous wave. It moves and changes with time. So the change that going to happen in this wave from the values or the changing of the values of the voltage, it will also mean a specific meaning or a specific reference in our data. So using this wave or using this continuous wave, we are transmitting or transmitting our data. So the examples of analog signals: video and audio transmissions are often transferred or recorded using analog signals. The composed video coming out of an old RCA jack, for example, is a coded analog signal, usually ranging between 0 and 1.073 volts. Tiny changes in the signal have a huge effect on the color or location of the video, which means that in the old RCA jack, they transmit the data using an analog signals. So the analog signals or the analog signal, it has the range of the analog signal, it is between 0 and 1.073 volts. Tiny changes in the signal have a huge effect on the color or the location of the video. So that means that when the color is changing or the location of the video is going to be changed, that means that the value of the voltage or the value of the analog signal or the value also of the wave, this continuous wave, is changing. That means that it will change or it will affect our color and video. So the second signals is the digital signals, and these, by the way, are the most simple and used and very easy signals that we are going to use after that, and it is the most useful signals or the most useful tool that we are going to use to transmit our data. So the digital signals. A digital signal is a signal that represents data as a sequence of discrete values. The most common digital signals have only two levels: one off, or zeros and ones, or 0 and 5 volts, etc. Which means that the digital signals have only two values. The first value is the 0 and the second value is the 1. The 0 represents that there is or there isn't any voltage, and the 1 represents that there is a voltage. So that means that the 0 represents the off and the 1 represents the on. Okay, or also the 0 represents that there isn't any voltage, the 0 volts, and the 1 represents that there is a voltage, and this voltage will be, I guess, usually it is 5 volts. Okay, so this is the digital signals. So the sequence of these numbers or the sequence of these two levels, it gives me our code or our data. So if we have, for example, 01001011, that means a specific reference or a specific data that I will transmit. Digital signals are used in all digital electronics, including computing equipment and data transmission devices. When plotted on a voltage versus time graph, digital signals are one of the two values and are usually between 0 and VCC. The VCC is usually 1.8, 3.3 or 5 volts. So the zero, the value of the zero, it is absolute 0 volts, or absolute, that the 0 means that there isn't any voltage, and the 1 means the VCC, that there is a VCC, or there is a voltage, and this voltage, it usually between 1.8, 3.3, or 5 voltage. With the correct circuitry often included in ICs, the IC, the integrated circuits, are the components, or they are the digital components that we are using to transmit our digital signals. The signals are very robust to noise. Zeros stays zeros and one stays one, which means that the very good thing about the digital signals, unlike the analog signals, that the digital signals are very robust to noise, which means that we can't affect our wave or our sequence with a noise. But the analog signals, it may get affected by the noise, and the noise, when the noise affect our analog signal, it will give us a huge effects on our, for example, the videos or the audios or any data that we are transmitting. Unlike the digital signals, when there is a noise exist on our digital signals, it will not going to affect our data or our data transmission. So that means that the zeros stay zeros and the ones stays one. The analog versus the digital. The analog versus the digital electronics operate using the first thing that we are going to show is the digital circuit. So the digital circuit, or the digital signals, operate using discrete signals with binary signaling along the wires, just on-off pulses. We have said that, okay? And generally, digital circuits are easier to design and more expensive and require more power to do some same job, if job can be done in analog. Okay, so that means that the digital signals or the digital circuit is a very easy to design, but it is very expensive and require more power to do the same job, if the job can be done in the analog, of course. Okay, so this is an example of a digital circuit. First thing that we are going to get is our digital sequence, or our digital data from this generator, and then it will go to the clock divider. The clock divider is an IC, of course, that takes the 8 million pulses and transmit pulses per second and transmit it to 1 pulse per second. It will lower the speed of our data transmission. And the counter counts up to 8 outputs binary. So it gives us our 8 outputs binary. The binary to LED display. So this device takes the binary and translates it to our LED display. So it takes this pulses and translated to specific voltage going to a specific pins to our LED display or our 7-segment display. I have explained the 7-segment display and how does the 7 segments display works. The analog electronics. Majority of components we have seen are inherently analog. So if you don't see any blocks representing ICs, it's probably analog circuit. So that means that the digital circuit, it has the thing that it is very famous with is that there is a lot of ICs and blocks of ICs. But the analog circuit doesn't has a lot of ICs. It has a lot of capacitors, transistors, for example resistors, and all of that. But unlike the digital circuit, the digital circuit has a lot of ICs and blocks that represent the ICs. So generally the analog circuits are more complicated, but often more elegant, more suitable to noise. Okay, so that means that it getting affected with the noise very easily, unlike the digital signals or the digital circuits. So this is a circuit of an analog, or this is an analog circuit. So the first thing of the analog, it has the audio in. The audio in the data of the audio getting transmitted by or using the analog signals. First thing is the filter circuit. We have a circuit for filtering our for filtering the noise. We are going to explain the circuit of the filter and the buffer and the amplifier after this or in the next lectures. So be sure that we are going to explain these circuits, because these circuits are very important in our job. So the first thing that the signal comes to the filter, and the filter the wave or the analog signal from the noise. After that we have a buffer, and after the buffer we have the amplifier. The amplifier amplify the audio or the signal that comes from our this part or audio in. After that we have the current amplifier. It will amplify the current. After that we have our speakers, and the speaker will translate the analog signals to a noise. So that's it in our lectures. Thanks for watching, and I hope to see you in the next lectures.